Hello, good morning, and welcome back to the Demo Deep Dive Show. You are here on the Red Hat channel, joined by a very special guest. Today, I've got James Harmison. He's a senior principal TMM, and he's going to be joining us for this special episode where we're going to recap Red Hat Summit, what went down, and because he is an absolute genius, he's going to walk us through a really cool AI-driven demo for GPU as a service. So, James, thanks so much for being on the show. Feel free to introduce yourself, give us a fun fact, whatever you'd like.
Hey, let's see. I've been at Red Hat now for about 6 years. I'm in our AI business unit right now. I've done roles in sales and architecture and things like that. Fun fact is that we were just talking about this a little bit. I used to be a helicopter mechanic not too long ago. So that very different career in those days.
Was, we work with helicopter companies, right? Airbus and stuff. So I guess it all works out. That's cool, man. Well, nice. Glad to have you on the show. And for you watching, feel free to let us know where you're tuning in from. And if you haven't joined Demo Deep Dive before, you're in for a treat. This is the show where we go back kind of to the technical roots as Red Hatters and talk about the technology and open source projects that power all of these, new innovations in AI, in virtualization, in application development. And if you actually come to interact.redhat.com or scan the QR code at the top left of the page, you yourself can experience some of these cool demos that we're going to be walking through today. And again, they cover lots of different topics. So AI, app dev, virtualization, Ansible, and so much more. And all you have to do, if you're interested in, say, for example, one of these demos, one of them that we'll walk through today, you'll just click on it and you can get started with the demo from there. But let's go and kind of walk back a second, because we talked about Red Hat Summit. And if you had the pleasure of joining us in Atlanta last week, it was an absolute blast. But a lot of people tuned in live. And James was there in person. And, the big ask is, what went down this year at Red Hat Summit? What were the key themes and what were the cool conversations that you had?
Yeah, I was talking a little bit about this with Rohan earlier. I'm in the AI business unit, so I was working in our AI booth for the majority of the time. And one of the things we see a lot at Summit is that the attendees are like systems administrators, maybe application developers, platform engineers, that kind of persona. And as our AI portfolio has been built out and matured, we've had a history of people being like, oh, what's this AI stuff? Oh, Red Hat does AI. What do you guys do? And I think one of the things that happened this year that's really cool is that a lot of people were asking really hard questions about practical implementation. We've seen a lot of people that in the past didn't really know what was going on with AI. This year, they have been operationalizing it. They've been putting it into production. And so all the questions that we were getting from attendees and the conversation in the hallways, which is always, the best conversation is, it was all about like real problems that people are having. And they're like, oh, this thing takes so long to start up, or I'm having major issues with request routing over here, or I'm struggling with like GPU resource management from our central pool. So that was the big takeaway for me from the AI perspective, was that this was the first Red Hat Summit where it really felt like people had rolled their sleeves up and been doing this stuff for real. So awesome conversations all week.
Yeah, well said. I was there a little bit with you in the booth at Red Hat Summit, and it was just fun because one question would be from a developer, one question would be from someone in ops, someone would be platform engineer, someone would be a sysadmin. And it's interesting the angle now that we're getting for all these new types of developments, right? People are building RAG or agents. Or on the other hand, people need to, partition a GPU, or they want to, monitor who's using the LLMs. And so it's really cool now that we're seeing both of the angles, because I'm a more application developer side. Give me an API, I'll call it. But then, the keynotes at Summit were all about, you're serving a model, what about guardrails and stuff like that. So, did you have any preference to some of these cool demos that you saw at Summit last week?
I mean, I'm a hardware nerd, so at the end of the day, seeing all of our hardware partners that brought some bare metal to come and hang out with was probably my favorite part. Looking at all the different configuration, all the embedded water cooling they've got in the server chassis these days to keep them. I was seeing like 2U server chassis with 8 super high-end graphics cards in it because they were able to water cool it and keep everything compact. So that was probably my favorite stuff I was looking at. But
It's dope. Was that on the floor?
yeah, right on the expo floor, they had stuff set up.
That's
Yeah, it was
dope.
awesome.
Nice. Well, super cool, super cool. If you didn't see the keynotes, feel free to check them out on the Red Hat channel. They're on the live section, and it's really cool seeing CEO Matt Hicks and a lot of our partners come up and share those stories about what it takes to move into production with AI. Because I feel like years past it was experimentation, POCs, but now we're on the other side of like, yeah, it's already running, but here are the challenges for authentication, for partitioning, so much more. And I guess partitioning is what we're going to be kind of talking about today, right?
A little bit. Yeah, we're talking a little bit about the models as a service as well. Sort of central platform provider, self-service to developers, that kind of story.
Nice. And that's been a huge, it's been huge, like in popularity, right? The models as a service approach, right? Because maybe correct me if I'm wrong, but I think what we had seen in organizations is that you have one team in data science and they've got their own LLMs running, and then one team working on features and they've got their own LLMs running. And so it's like, why run the same models across the organization when you could centralize it? Is that kind of the premise of models as a service?
To some extent, and then for the particularly large customers, like we see it a lot in government and FSI, the financial services industry, we see a lot of like, not just this is the data science team, but like this is this line of business's data science team, and this is this other line of business's data science team. And so the sort of duplication of roles aligned across all those lines of business, or like mission, you would say, for the government customers usually, means that a lot of them are doing the same kind of work and they need the same kind of resources. So managing those centrally, whether we're talking about the GPUs being managed centrally and provided, or whether we're talking about the models, right? Providing token consumption-based access to those internal lines of business and mission customers.
Right. The kind of transparency of who's using the model, who's doing what, and making sure that the models or the GPUs are used, right?
Yeah, a lot of them have spent a lot of money on a lot of GPUs, right? And keeping them running, just turned on, takes a lot of power. So it's all about efficiency and trying to get return on investment, right? You've laid out the capital expense of the hardware, and now you've got to make it do good work.
Yeah, that's the name of the game. Well, awesome, man. I'm excited to see this demo that you're going to walk us through. It looks like, yeah, you've got your display up here. Thanks, Rohan, our guy working in the studio right now to make sure everything is moving smoothly. So, yeah, feel free to walk us through. I might have a couple questions and stuff, but I'm very interested to see what this all looks like when you kind of combine the layers, right? I guess you'll probably walk us through what that looks like.
Yeah, so I tell this demo from the story of a couple of different perspectives, because whenever we're talking about this like service provider, service consumer sort of world, you really need to think about it from the perspectives of like the person doing the providing and the person doing the consuming, right? So I start off in this administrator perspective in this demo. It's an OpenShift 4.21 cluster. At the time that I recorded, this was the newest stable version. So this cluster happens to be in Amazon. You can see here, one of the nice things about the way that OpenShift views its infrastructure is that it doesn't matter what your underlying infrastructure provider is, right? You have this consistent set of APIs anywhere in the hybrid cloud environment. And the same is true for GPUs and accelerated work. So I'll show a little bit of that in a moment too. We've got OpenShift AI 3.4 installed. This is the release that GA'd last week during Red Hat Summit. So when I recorded this, it was with a nightly build before the release. But yeah, 3.4 just came out and it includes a bunch of the features that we use in this demo. The overall idea is that OpenShift AI, OpenShift, for those familiar, OpenShift is an application platform, right? It takes Linux and Kubernetes and 34 cluster operators and builds an application platform out of your infrastructure. OpenShift AI takes that application platform and extends it to be an MLOps platform. And so the configuration for OpenShift AI all lives here. We're going to detour a second from the admin. We've provided the platform. It is an MLOps platform. We go look at our nodes. In this case, I'm on Amazon. So I'm using G6012X large instance types on Amazon. These have NVIDIA L40S GPUs, 4 per node. And I could be using different infrastructure, right? It could be bare metal. It could be a single node OpenShift cluster. It could be in a different cloud provider. It could be on a hypervisor, right? There's a lot of flexibility here. You get the GPUs into the instances, and then OpenShift AI lets us consume them. So this admin has used the models as a service feature in OpenShift AI 3.4 to deploy 2 models. He's deployed Gemma 4 and a Llama 4 Scout model. These are pretty different models. Right, Gemma's known for being really good at tool calling these days. Everyone's pretty happy with its performance, right, per parameter. And Llama 4 Scout has a superpower of a very long context window, like very, very long. So being able to provide these 2 models that are maybe useful for different scenarios in the models as a service view is like a very beneficial thing to have. You'll see that they're consuming the L40S GPUs. Excuse me. And I've just configured a couple of resource configurations for those, like CPU and memory. One thing about the default deployment path for models as a service is that it uses LLMD by default. So LLMD is an orchestrator. Excuse me. LLMD is an orchestrator for VLLM instances. It intelligently wires up multiple replicas of VLLM and then ensures that the requests go to the best instance to handle every individual request. Using LLMD here in this demo is particularly useful because if you're a central model provider hosting multiple models of different types, it's not guaranteed that they're going to have like a consistent amount of load each. You're not going to be able to say like, oh, here's my resources for this model and then I'm done. You're going to need to have some flex, right? Like one model will be busy on the weekend when people are doing a bunch of batch work, like processing documents and stuff. And a different model would be busy during the week when your application's really busy and all those tool calls are happening, right? So LMD has some, it's called load-aware autoscaling, and that load-aware autoscaling functionality underneath mass makes a lot of sense when you have a bunch of different models provided to a bunch of different LOBs or teams or applications, right? Mm-hmm. So just a little fact that's tucked in here. We'll see the implications of the autoscaling later, but
that's awesome.
The admin view, right? You have this pool of resources that you've spent money on, and you're responsible for making them consumable. So you have to keep observability on a couple of things, like what's the resource utilization look like? What do the health of my model server endpoints look like? That kind of thing. So the admin has this high-level view that gives you like some information about what's going on with the model servers, with your GPUs, et cetera. And that's the setup. That's the environment. We shift from this to the developer perspective. Was there anything you wanted to ask about the admin one?
So admin, I guess it's, yeah, how did the observability work? It kind of looks like a kind of Prometheus type of setup, right? To make sure that we're utilizing the GPUs. How's that all come together? That's pretty cool.
So OpenShift has built-in a Prometheus support. So there's a default Prometheus deployment called the cluster monitoring deployment. There's also an optional like second thing you can enable in OpenShift called user workload monitoring, which runs a parallel Prometheus stack and Thanos and a bunch of stuff that makes it so that the monitoring stack is sort of cohesive across both things while isolating the blast radius. Cool. OpenShift AI for all this model serving stuff expects that the user workload monitoring in OpenShift has been configured, and it uses the OpenShift user workload monitoring stack to collect these metrics.
Very cool.
There's some nuance to the ways to do metrics, and there's some flexibility in other options, but the default here is that it goes into user workload monitoring.
That's awesome.
These dashboards, really interestingly built right into the OpenShift AI interface, come from Perses. So in this case, these dashboards are Grafana compatible JSON embedded directly into the OpenShift AI UI. If you had a Grafana instance that you wanted to use, you could build the same dashboard over there, get these over there. But here it's using Perses, which is just like a slimmed down way of doing these visualizations. And it's just reaching that Prometheus stack.
That's very cool. Yeah, because I feel like, traditional LLM observability is like, oh, it's a black box, right?
Yeah.
You're going to see how much it costs you, but you're not going to know much more beyond that. But when you're doing, serving thousands of users, right, you need to know like the time to first token for like the bottom right, like the slowest 10%. Like, is it going to be 50 milliseconds or is it going to be 50 seconds, right? And that's huge.
We get to that here, and we start talking about the P90 TTFT in particular as like the metric that we would establish like an SLO around, right? Like we'd say, hey, we don't want our TTFT P90 to go over 10 seconds or 30 seconds or whatever, depending on our load, right?
Yeah, that's huge.
And so, yep, the goal here is just to have these OpenShift AI components support you meeting those SLOs, support you measuring those SLOs, and to give you like an idea of where you're going to need to tweak configuration in order to optimize in the future, that kind of thing.
That's awesome. Nice. Thanks.
Yeah. We do go into some of the application developer or the MLOps engineer perspective too, because there's some different observability that they care about, right? Here we're talking about, I'm a service provider. I'm hosting this model. Is my service good for my tenants? But from like the application developer perspective, you might be like, why did this model make that decision? Or how did it react to this user query? Those kinds of things. So we show some of that stuff too. There's a lot in this demo. It's a broad demo. All right, so the perspective of the app dev, right? This is a guy who's building an application with agentic AI integrations. So the team that builds this might be like a cross-functional team with an MLOps engineer and some like traditional application developers, front end, back end, full stack, etc. Here, it's just me playing a part. So I have just one persona. I am developer. The application this developer is deployed. We have this fictional company that we call Fedora, as in like FED space AURA, which I think is a fun name. Fedora. So our Fedora capital company has this banking application, and it's sort of like a multi-user banking application. It's got a landing page for our customers, but it's also got some integrations into some like back-end business logic with different perspectives for our internal users to be able to access the data. And it has this AI assistant baked in, and we're going to use a mix of a bunch of things in this Fedora app. First off, it's a public application on the internet, is the idea, right? So you don't want to put a bare AI model or a bare agentic system straight on the internet. You need guardrails. So we use OpenShift AI, has Nemo guardrails support. Actually, if I go to the beginning of that video, how do I get to the, I don't even know how to use the player to get to the beginning.
Oh, you can just hit the left hand, left and right.
If we go right here, you can see this is part of the Trusty AI API group, right? It's a subcomponent of OpenShift AI. And it has native Nemo guardrails integration as of 3.4 from last week.
Ooh.
Yeah, lots of cool features landed in 3.4 actually. So many features. So Nemo guardrails is really cool because it lets you do a mix of a bunch of different types of guardrail configurations. When people think of guardrails, usually the first thing we think of is a regex detector, regular expressions. So you say like, this is a bad word, or bad words might look like this, right? And so Nemo guardrails lets you do some regex detection. So you can see here's some regexes. Like it's easy to find a social security number with a regular expression, no problem. But you'll notice that it had these like models configured as well. So the Llama 4 Scout model is one of the models we're using here. But then there's this like safety detector, right? So what's happening here is that we're able to take these large models and give them plain English instructions, which I think, yeah. So we're able to give it plain English instructions. Like here's a collection of the OWASP top 10 categories for like AI safety. And I would like you to enforce out of this top 10, like these things this way. And because you're using a smarter model, like a full-blown language model, it's able to evaluate those plain text instructions and do stuff, which is really super, super useful to have that flexibility. And we're bringing that alongside a traditional like guard model. In this case, it's a Llama guard model. And then alongside simple regex detections. So this flexibility that Nemo Guardrails has, where we're able to do like traditional guardrailing at the same time as more complex guardrailing with more capable models, is super useful. And that Llama 4 Scout model becomes a great choice because it has a super huge context window. It's able to make summarizations and judgments on text really quickly. And we know that like all of our safety instructions plus the entire user prompts are going to fit into its context window, right? So that's where, hey, this is a really good model to use for this.
Right.
Let's see. So from the developer perspective, this guy doesn't have a lot of privilege in this cluster. He's got just his one namespace pretty much, right? And from this environment, he's able to come see this AI asset endpoints. And here's where he sees, he's got a couple of models here, and this thing is sort of in the way of some of the text there. But the models list shows anything that's local to the project that you're looking in. And then it also shows all the mass ones that admin hosted. Gemma 4 and Llama 4 are here. He can view his endpoints. He can come over to the APIs key view and manage API keys against subscriptions. So a mass subscription is an abstraction that lets you say like one or more models for one or more groups of users for a certain rate limit, right? So if you wanted to say like, I need a quality of service guarantee, you could use different rate limits on different subscriptions to get that stuff going. Users can see their own, admins can see all of them, expirations are configurable. I'm going to move a little quicker to get through some of this real quick. So the application has this web UI. You can click the button, it pops open the interface and asks the chatbot a question. There's some other stuff on the app. It's kind of an example. This agent knows Fedora Capital's products specifically, right? So it's able to give me on the rails information about those specific products. And at the same time, the same chatbot, and actually if we look at this one's probably pretty interesting to look at. This is a different perspective, not the landing page, right? So this is like a loan officer who's coming in and doing approvals and stuff. When they ask a question that says something like, organize it based on his social security number, if the social security number is in the thing, it's like, oh, no, the guardrails stopped me. So we have this complex app. One of the things that's really cool about the guardrails is that the models are hosted externally. So I can have different deployments of the lightweight guardrails with different configurations. And I'm sharing the same models. So I can have different guardrails for different personas very easily. And then the point of this demo, really, we have the scenario, right? A developer building an app, lots of personas. He's got safety stuff involved. He's consuming models. He's hosting some models using GPUs that admin has made available. What do you do, though, when you're centrally hosting a service and your application gets busy, like really, really busy? And so you're starting to get beat up, right? The developer isn't running the models. He's not thinking about LLMD or VLLM or GPUs. He's just got his endpoint, right? So he's expecting a certain amount of service. So this is where we go back to the admin view. And I have a confession to make. Starting up 6 queries at once was a really fun bit of theater, but I ran a load generation script on the side instead to actually do this. So the admin can view these token-based metrics. This is a dashboard that I didn't pull up earlier. I was looking at these cluster and models dashboards. So this is showing individual users, the subscription abstraction, the model they're hitting, the tokens. This is total input and output tokens. We can break it up more in the metrics, but the dashboard here is just high level. And we can see that I do have auto scaling configured for the models that he's running. So as we let the load balancer or the load generator ramp, we have 1 copy of the model running. And then for this chunk, you can see the token requests continues to climb, and then new container spins up on its own. The auto scaling here is called workload variant auto scaling, which is a really complicated word that means LMD knows how to scale your model servers based on the ways that model servers experience load. So in a normal like auto scaling situation, you would auto scale based on CPU or memory utilization, right? You'd be like, oh, my Node.js app is using a lot of memory right now because the heap has gotten big, so we need to go spin up another replica. That doesn't work with these, with generative AI models. So workload variant autoscaler knows, hey, VLLM pods experience load through 2 main signals. Queued requests, so requests that VLM's not processing, and KV cache utilization. So if the KV cache gets really saturated, then it's not going to do well at handling new requests. So we'll spin up a new replica. This model starts loading right away. That previous chunk of video was like, I think in real time. I don't think I had the fast forward indicator up on it. But one of the things you can see is as my load generation is ramping, the TTFT is climbing, right?
Right. That's bad.
That's bad. That's bad. This is a bad experience. So P90 TTFT means the slowest 10% of requests are experiencing this much time to first token. So between when you press enter and when you start getting tokens come out and words pop up on the web page, ultimately, 10 seconds is like a long time. 10 seconds is a lot of the spinner spinning. So no good, no good. Our new pod comes up, and you can see the ramping has been happening still because I have a very aggressive ramp on the generation script. So at this point, it's sitting at about like 30 concurrent requests happening just continuously. And every time one finishes, a new one spins up. So 30 concurrent requests against this like single replica pool. The new one just came ready. You can see on the graph, we have 2 replicas now. And basically right away, as the metrics start to continue to saturate, you can see that this immediately nosedives.
Nice.
One of the things about this graph is that this is averaged over the past 30 seconds. So it would have to run at this rate for 30 seconds to see what the real value is because it's trying to smooth the graph, right? And then we let it cook for a little bit, and our TTFT is down under 5 seconds again, just like that.
Nice.
You can see this request queue. This is what I was talking about, like the number of requests that are sitting and not being processed. Basically, we got our new instance up, and suddenly these 2 can handle the load, no problem.
Nice.
Total throughput goes up. Success rate's going up, getting back to 1 again. Everything's looking good. Let's see. All right. We come back to the application now. And this is the CEO perspective, right? This is a guy you don't want to have to wait 10 seconds while the spinner goes. And I did this in the middle of the load test. It auto-scaled. The CEO is able to come in and chat. Everything's working fine. He, is able to ask his assistant questions about the existing, like the state of the business. So the idea, metal to agent, right? Everything you need to be a platform provider, a token provider for internal consumers, and everything you need to build on as an application developer, building agentic AI for production these days.
Hell yeah.
Move quick.
That was awesome. That was awesome. And I like how you know all of these different projects plug in. You've got VLLM for the inference server, you've got LLMD for the orchestration, you've got metrics that you know integrate back into OpenShift. So it's all kind of probably Prometheus compatible, if I'm understanding correctly.
Yeah, it's in Prometheus itself.
Right. And so it's like we're not building new things here. We're just kind of, you know, using the underlying orchestration systems of OpenShift, of Kubernetes, to just then deploy these new applications. So it's pretty cool how it all fits into kind of, you know, what we've already been building on for the past 15 years with cloud native. But
Shoulders
now
of giants.
Shoulders of giants, right? They had to walk so we could they ran so we could walk so we could run. One of those things. So awesome. Nice. Well, so for Red Hat AI Enterprise, where do people go next? We've seen this really cool demo. We've seen the platform side, the app dev side, observability. Where do you recommend people start?
A bunch of options, right? So first off, come to interact.redhat.com if you want to come see some of the demos of what we've got going on. And once you think you're ready to have a conversation, you can talk to your Red Hat account reps, or a huge part of how we're doing this is with partnerships with OEMs. So the people that you normally buy your servers from, you can have a conversation with them about Red Hat AI Enterprise, and they're happy to have it. We've been working with them for months now to make sure that all this is easy to deliver and easy to make real. So
yeah, I know you've been doing a lot of work on that front. Before we close off, what's one thing that you're looking forward to for the next year? For 2026, what's your prediction? At the end of the year, what will be the thing that we look back on in AI that we're like, wow? Or in your case, like that you've worked on that you're like, wow.
Yeah, the one I'm most excited about is the stuff we're doing with the MCP gateway as part of our AI gateway initiative. So models as a service is the first thing we're doing in this AI gateway, but we're moving to a world where self-serving or self-servicing MCP server access and handling identity and mapping OIDC to Spiffy and Spire, and having our workload identity be associated with our user identity and getting all that stuff ironed out. I think that's going to unlock a lot of capability for enterprises at scale. So I think that's going to be a big inflection point for us. I'm pretty excited to see how it works out.
Nice. Yeah, I think that's definitely one of the top things. I mean, everyone's running an MCP server probably locally with little to no security. That's been downloaded from a random GitHub repo. Not all cases, but many cases. So it's kind of the Wild West right now. And I think that the work you guys are doing to standardize that, to add security governance on tools is the future, right? If everyone's building agents, then agents need security, or else we're going to be vulnerable, right?
Yeah, it's a big problem. We talk a lot about like shadow AI, where in the back in the old day, before everyone had a nice cloud application platform, everyone would go stand up their own infrastructure kind of wherever and build their app there and make stuff work because like IT was in their way. And we've really moved past that in the application development space, but we're not quite at the level where that works in the AI space. So what are people doing? Oh, they're going to Claude Code, or they're going to Codex from OpenAI, and sometimes that's good and it's effective and it's accomplishing things, but sometimes it puts the business at risk, right? And so helping IT organizations service their incoming developers so that everything's easy for them to do the right thing and go through the right policies. And maybe it goes to Claude, maybe it goes to GPT, but it's going through organizational policy and control. That's where we need to get. And as long as it's hard, shadow AI will exist.
And I mean, we've seen a lot of examples of that happening in the past. So I think as these tools continue to emerge and get popular, developers still going to use them. I mean, it's like, all my other friends are using Claude. Maybe I should get on the Claude Code, right? Or whatever AI tool it is, right?
Heroku, remember Heroku?
everyone else is doing it. Say what?
Yeah. Remember Heroku taking
Heroic.
the app dev world? Like
Yeah.
history doesn't necessarily repeat, but it does rhyme. So
Yes. I love it. I love it. Well, James, man, this has been a fun episode. I really appreciate your time. I know the folks watching appreciate your insight because, that's kind of the future of where you and Red Hat and a lot of others in the community see, the future of enterprise AI going. And the demo was a great way to see that. So remember to check out that link up there to interact and check out these demos yourself. Is there any closing words that you'd like to share with us before we wrap up today's episode?
I'll just say keep doing cool things.
Yeah. All right. Keep doing cool things. Keep building stuff. Keep using
Yeah.
open source. And enjoy the rest of y'all's week. All right.
Bye.
Cheers.